All right, class. Today we're doing the homework for Unit 1, Lesson 5, which is to convert repeating decimals to fractions. Problem number 1, my pen doesn't work. Problem number 2, just kidding. Problem number 1, 0.777 dot dot dot. The dot 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 signifies that this 777 is going to continue on repeating. And so first step is to set x equals and then try to simplify this. Look at the pattern. We see a repeating 7 up here. So I'm going to write 0.7 with the repeating bar above the 7. So next, I have my decimal point right in front of the repeating 7. And now I want to get one set of this repeating sequence or the pattern to the left of the decimal point. So to do that, since there's only one digit within this repeating decimal bar, I only have to move this decimal point one spot. And as we talked about in class, to move the decimal point one spot, we multiply by 10 on both sides. Give me 10x equals 7.7 repeating. And now we have one copy of that pattern, which is just a 7, to the left of the decimal point. And so now I can move on to my next step, which is to get rid of this repeating decimal portion. So I'm going to take my original x equals 0.7 repeating, and I'm going to subtract that from 10x equals 7.7 repeating. Subtract x from this side, subtract 0.7 repeating from this side. Subtract 1x, and over here subtract 0.7 repeating. 10x take away 1x gives me 9x. 7.7 repeating, take away 0.7 repeating. There goes my repeating decimals. So now I have nice clean numbers. 7 take away 0, 7. 9x equals 7. Whenever you have a number next to a letter, that means they're multiplying. So this is the variable, this is the coefficient. And our last step is to divide away from the variable so that we can isolate the variable and get our final answer. So we're going to divide both sides by the coefficient, which is that 9, and x equals 7 over 9. So up here, our 0.777 repeating, that's the same thing as writing 7 over 9. That's problem number 1. Remember, you can always pause this and rewind it if you need to see something for a little bit longer. Problem number 2, we have 0.08333 dot dot dot. Make sure I got that right. All right, so starting up, we've got to go x equals, and we need to try to simplify this because I don't want to try to put that down here. So I see here's a repeating series of 3's. So I'm going to copy down 0.08. And instead of writing a whole bunch of 3's, we write that repeating bar above that last 3, or the first 3, right? And now, from here, I need to see, well, what do I need to do? Well, I see there's 2 digits to the right of the decimal point before the repeating. And I want to get that decimal point right here so that when the time comes, I can subtract from both sides and get rid of that repeating decimal. So I'm going to move the decimal point 1, 2 times first. To move the decimal point to the right, we multiply by 10. And since I'm moving it 2 times, we're going to multiply both sides by 10 to the second power. 10 times 10 is 100. 100 times x is 100x. Multiplying by 10 to the second power moves that decimal point over and gives me 8.3, still repeating 3. So now I'm going to use this later on when it comes time to subtract. So next, what we're going to do is we are going to try to get one set of this pattern to the left-hand side of the decimal point. So to do so, since there's only one digit, to move this over one spot, I only have to multiply by 10 on both sides. So I'm going to multiply by 10 here and multiply by 10 here. 10 times 100 is 1,000. x, and over here, we're going to have 83 as our whole number, dot, or decimal point, and then continue with that repeating 3. So now I have 1000x equals 83.3 repeating. So I have one set of that repeating pattern to the left of the decimal in the whole number section, and we still have it over here on the right-hand side, which we're going to get rid of right now. So just as I mentioned, we're going to use this 100x equals 8.3 repeating. We're going to subtract that on both sides here to get rid of that repeating 3. So I'm going to subtract 100x from the left, and I'm going to subtract 8.3 repeating from the right. 1000 take away 100 is 900. Make sure you can still see that. And our repeating 3's get canceled out. 83 take away 8, and we get 75. So now we have 900x equals 75. And again, we're trying to get this x by itself. So we're going to divide both sides by this coefficient 900, and we will get, see, our camera's still showing it, x equals 75 over 900. And that can be simplified. We can divide both top and bottom by 25. So 75 divided by 25 gives us 3. And 900 divided by 25 gives us 36. Now I see that we can go one more time. 3 goes into 36 evenly. It goes in evenly 12 times. So 3 divided by 3 is 1, and 36 divided by 3 is 12. So my answer is 0.083 repeating is equal to 1/12. 1 divided by 12. That is problem number 2. Next. Problem number 3 reads 0.0909 ... Or actually, we don't even have a ... on this one. It just stops right there. So convert the following decimal into a fraction. Okay. So this is the tenths place. This is the hundredths place. This is the thousandths place. This is the 10,000ths place. The fourth digit to the right of the decimal point. This is the 10,000ths place. So I'm going to write 909 over that place, 10,000. So 0.0909, not repeating. You left off the decimals or the dots out here, maybe on purpose, maybe by accident. I don't know. But this right here, converted to a fraction, equals 909 10,000ths. All right, moving on to the next one. Number 4, 1.1666 ... So now here we got the dots again, telling us we got a repeater. So to rewrite this, x equals 1.16, repeating. So again, we're going to follow the same steps we did on problems 1 and 2. We want to get this decimal point right up before it starts repeating. That's only one spot away, so we're going to multiply this side by 10 and this side by 10. 10x equals 11.6 repeating. This is what we're going to use to subtract when the time comes. So now I have one digit underneath this repeating bar. So I'm going to multiply by 10 on both sides, yet again, to get one set of that repeating number to the left of the decimal point. 10 times 10 is 100. X With this decimal point one spot, we end up with 116.6 repeating 6. And so now we got to get rid of this repeating decimal. So we're going to subtract what I had mentioned, that 10x equals 11.6 from both sides. Subtract 10x on this side because those are like terms, and it's equivalent from the right-hand side, 11.6 repeating. And anytime, again, when you're subtracting decimals, always line up the decimal point. 100 take away 10 is 90. 90x equals, our 0.6's cancel out. And now we have 116 take away 11. 6 minus 1 is 5. 1 minus 1 is 0. And the 1 doesn't have anything below it, so we just bring it on down. So now we have 90x equals 105. Divide both sides by that coefficient in front of the variable so that we can isolate the variable. Divide by 90. X equals 105 over 90, which we can divide both top and bottom by 5. And I'll use my handy dandy trusty Casio. 105 divided by 5 is 21. And 90 divided by 5 equals 18. Now I see 21 and 18 are both divisible by 3. So I'm going to go ahead and divide both top and bottom by 3. 21 divided by 3 is 7. And 18 divided by 3 is 6. 7 over 6. That is a fraction. It's also known as improper fraction, since the numerator, the top, is larger than the bottom, which is the denominator. But we knew that was going to be the case because we didn't start off with 0 point something. We start off with a number greater than 0 here. So we start off with a 1, 1.1666 going on forever. So number greater than 1, I should say. So 1.1666 repeating is equal to 7 over 6. So we only had 4 problems, not 6, 4 problems for unit 1, lesson 5. Thank you.